Live from Norwich with the best of the fest, the Naked Scientists.
Hello, yes, it is Dr. Chris Smith, that's me, and also Dr. Kat Arney, who's here this evening.
Hello, this is me.
We're here with you for tonight's update from the BA Festival of Science at the University of East Anglia in Norwich. And every evening this week, we're bringing the festival to you with a best of the fest roundup of the highlights of the day. And here's a taste of what's coming up in the next 30 minutes or so.
On today's Naked Scientists, you'll be finding out what this is. Need a clue?
It was how we used to do virtually everything for a better part of 2.5 million years.
Find out later in the show. In the studio, we'll be taking a closer look at the animal kingdom as Chris Little from the University of Leeds sheds light on the secrets of the deep.
I'm going to be talking about the amazing communities of animals that you find living in the deep sea at hydrothermal vents and cold seeps, and I'm going to look at it from a fossil perspective.
We'll also be joined by Paul Morris from Portsmouth University, who'll discuss if we can hurt the feelings of man's best friend.
I'll be talking about emotion animals such as jealousy in dogs.
And in kitchen science, you can learn how to make your own water fibre optics.
If light comes out of something like water at a very small angle, instead of going through it, it will actually bounce off. In fact, it's almost a perfect mirror.
And don't forget, of course, that you can take a look at our Naked Scientist team in action on our webcam. Just log on to bbc.co.uk, click on webcams, but of course there are no guarantees of exactly how naked everyone's going to be. It's been a very exciting day at the festival today, and for me, one of the highlights was meeting Sarah Jane Blakemore, not just because she's an extremely nice-looking lady, but also because she's come up with the answer as to why adolescents and teenagers are diabolical to live with.
Why is that then?
Well, in fact, the answer lies in the brain scans that she did. What she did was put some adults into a brain scanner and also some adolescents into a brain scanner and asked them to do a simple task where they were asked to plan how to do something. And they looked at which bits of the brain lit up. And what was really striking was that in the adults in the brain scanner, the front areas of the brain, the prefrontal cortex, and that's the part of the brain that's involved in processing the consequences of your actions, that was really strongly activated in the adults, but not in the teenagers.
You mean basically they're just not bothered?
Quite. So what they actually do is activate the part of the brain involved in planning what they're going to do, but they don't activate the bit of the brain involved in assessing the consequences of what they're going to do. And so it's very much a case of open mouth before engaging brain, and that's why they're so unbearable to live with.
I'm just not bothered, Chris. Anyway, well, I don't know about you, but I'm feeling pretty peckish now after a busy day here at the festival. But what should I eat? I mean, there's so much confusion about diet and health. I mean, off the top of your head, what causes cancer? What foods cause cancer?
Anything causes cancer. Black pepper, Earl Grey tea is known to cause cancer. Lettuce causes cancer.
What doesn't cause cancer? I don't know, pomegranates?
But not even air doesn't cause cancer, because oxygen is a very good way of causing cancer, isn't
Exactly. It? So, I mean, one week it's pomegranate juice, the next week it's broccoli, chocolate, whatever. So what should I eat? And there's all sorts of things about functional foods going on as well. I mean, the margarines that can reduce cholesterol or eggs that can boost your brain power. But to find out more, I went to several talks today that are all about food and the effects it can have on your health. So I heard a talk about nutrigenomics. This is researchers who are trying to find out how variations in our genes can interact and affect how the food that we eat affects us. So it's how our bodies use certain nutrients. It's a big area of scientific and commercial interest, and I think in the next few years we're going to see it really taking off. And Sian Astley from the Institute of Food Research here in Norwich gave a talk, and she was explaining how these genetic differences may mean that some people may be more susceptible, for example, to getting fat than others, or need more vitamins than other people. But it's very complex to work out how these genes really might work, because we've got so many genes and we eat so many complex foods. And some scientists are very sceptical about it. We heard from Helen Wallace from GeneWatch, who's basically saying it's all just marketing and a commercial thing aimed to make money from wealthy, healthy, worried people.
It sounds to me like she's got a point.
Well, I think she's got a really valid point. The fact is that it's the poor people in our societies, the poor end of society, that suffer most from diet-related diseases and poor nutrition.
And they're not the ones with the dosh to spend on these kind of interventions,
are they?
So
instead of tinkering around and spending research money on these, do I personally need to eat more blueberries or not? We should try and get the basics of health and nutrition right.
We're talking back to basics. What about where the solar system, where the universe, where the Big Bang came from? Because Brian Cox from the University of Manchester was here today, and he was talking about a project that's going to go live in 2007. It's the Large Hadron Collider, which is at CERN in Geneva, a 27-kilometre round circular sunken tunnel underneath the ground.
Basically a donut.
It's a donut, essentially, and it will be firing beams of protons photons around at just beneath the speed of light, as fast as they can get them to travel around, and then they'll be slamming them together with the same energy as powers an aircraft carrier travelling at roughly 30 miles an hour. So that's a huge amount of energy, and what they're hoping to do is to work out how it is that the universe actually came into existence after the Big Bang and where mass came from, because obviously there was a lot of energy with the Big Bang, but that energy somehow had to turn into mass so that the stuff which we're all made from came into existence. So that's going to be really exciting for next year. But it turns out that Brian also has an exciting secret, which I happen to know about, so I asked him about it. So here's a snippet of the conversation I had with Brian earlier today. Now, bear in mind, he'd just been telling me how he was going to hit one particle with another at nearly the speed of light. Here's the details of his interesting past. And talking of hits, you've had a few in your time, haven't you?
Yeah, I'm an ex-pop star. When I was 18, I got the chance to join a rock band, which you would do when you were 18. So I took 5 years off and went back to university when I was 23, which worked very well for me, actually. So I did rock and roll first, and then the interesting stuff when I was in my early 20s.
Are you going to tell us what those songs were?
Well, I was in two bands, but one of them, a band called D-Ream, which actually I joined whilst I was at university. So after I started doing physics, I had a hit called Things Can Only Get Better. So you could say that I'm partially responsible for Tony Blair's subsequent rise and imminent fall. When we did this song for him, we were asked if Labour could use it in '97, and we said yes. And we said, but you should give us a knighthood if you get elected. And in my recollection is that he promised to do that. And now I'm worried, because I reckon he's got a few months left to go through with his promise.
Brian Cox talking to me earlier today. Now, of course, as we have done every day this week, our Naked Scientist reporter Anna Lacey has been out and about around the festival, and today she's been travelling back in time.
Whilst looking at a demonstration of flint knapping, I asked Jo Theobald from Heatherset High what she'd managed to make.
I tried to cut a spearhead, sort of an arrowhead.
So what's the technique then if I want to go and make my own spearhead?
You have to hold the spearhead quite hard, the flint, and then you have to push down with this wooden tool, I think it is.
Despite being used by Stone Age people, flint and obsidian glass still haven't gone out of fashion. John Gowlett of Liverpool University explains.
Even today, obsidian volcanic glass is used by some surgeons for particular tasks, so stone's still with us.
Why is flint such a good material for cutting and breaking? Why use flint and not another stone, for instance?
Well, flint has really nice sharp edges, and it is just the rock, and it's really perfect for making tools.
But what is it about flint that makes it so sharp? Here's John again.
It's very fine-grained, and you can feel it's really sharp to the hand. I think it's because it's so fine-grained that it's so sharp.
The tools of ancient people aren't the only thing that people can see at the BA today. Later this evening, there'll be a partial eclipse of the moon. So I asked Thomas Cader from University College Dublin how ancient civilisations felt about such an event.
One common theme seems to be that people feel that this is a time when supernatural things happen, when things that shouldn't occur become pretty normal. There's a lot of folk traditions that suggest that this is exactly what's happening.
Coming back to the present, Shima Adia from the Space Division at Kinetic told me what's actually going on.
It's when the Earth lies between the sun and the moon, so the moon is in the shadow of the Earth, so it's not getting all the sunlight from the sun. So when we look at the moon, part of it is in shadow, so it looks like it isn't a full moon, whereas it actually is.
It's not just for lunar eclipses that science has uncovered the truth. David Starley from the Royal Armouries in Leeds told me how placing old guns under an X-ray can help separate genuine treasures from convincing 19th century fakes.
We're looking at a supposed 15th century gun, but in fact when we look using X-radiography, which we're using in the same way as a hospital will use it, to look under the surface, we can see that the whole thing is held together with a 19th century standard screw thread.
So what's the point in learning about ancient technologies when we have high-tech things like X-ray machines? Here's the flint napper, John Lord.
I think that's just important, I suppose, because we need to understand the past. You may have to go back to it one day, we don't know.
Thank you, Anna. So, Naked Scientists, Chris and Kat, and we're here with you for about the next half an hour. And we're going to be talking in just a second with Paul Morris from the University of Portsmouth about whether or not animals really have emotions. And shortly afterwards, Crispin Little from Leeds University will be talking to us about hydrothermal vents, in other words, areas of the seafloor where hot water emerges and sustains all manner of bizarre life, and his discovery that he's announced today, which is methane seeps, where methane comes out from the seafloor and promotes the growth of all kinds of exciting creatures. And he's brought some examples of them here to show us, or at least what's left of them. First of all, though, let's kick off with Paul. Hi, Paul. Thanks for coming along.
Hi.
Now, animals and emotions. How do you study that?
Well, studying emotions in even people can be quite difficult because you have a problem of how do you know what's going on in anybody else's mind? And all you can really do is look at the context and look at the behaviours and try to piece together a story from that.
So which animals are you looking at, principally?
I'm interested in actually non-primates. A lot of work's been done with chimpanzees and gorillas, but I'm very interested in more domestic animals. So cats, dogs, horses.
Okay, and so how do you actually go and find out whether, say, a dog is embarrassed? Because a person, I know when I'm embarrassed, but you can't ask a dog.
Well, there's the same problem with sort of non-linguistic humans, infants, and the same sort of arguments apply. And all you can do is have a look at the contexts that are occurring and have a look at the behaviours. And if the contexts are appropriate and the behaviours are appropriate, you think that it's fair enough to conclude that you might give something a particular emotion label.
So that might be, say, if your dog's made a big puddle on the floor and you can see it looking rather embarrassed. Because my dog used to do that. When you could tell when she'd done something wrong. You didn't know what she'd done yet, but you could tell.
Well, I wouldn't actually go for things like embarrassment. The scientific literature, almost everybody would agree that most animals have what they call primary or basic emotions, such as anger or fear. The actual work I've done has concentrated on the emotion jealousy, and that's what I've got really the most definitive evidence for. I would be slightly suspicious of claims of things like embarrassment and guilt in lots of animals.
So how do you actually go about doing the research that you do on jealousy?
So all you can ever do with any non-linguistic being is actually really from an ethological point of view is actually film them. So you actually look at some context. So for example, the reason we concluded that dogs were being jealous is that if you see them in a social triad, for example, of the owner, the dog, and some interloper, either another person or another dog, and what will happen is that if the owner gives a lot of attention to the interloper, the dog gets actually very upset, will try to push in between, will get aggressive towards the interloper, and by any standard definition of jealousy, that's jealousy.
From an evolutionary point of view, why is that important, though?
Well, I think for any group species, obviously there's elements of sexual jealousy, but also there's elements that alliances and social alliances are extremely important. So that anybody who's trying to actually disrupt a social alliance or gain an advantage in a social alliance is going to be a potential threat to any individual.
And are some dogs more jealous than others? Is there any way you can bring them up not to be like this?
I don't know if there's any specific ways you could bring them up, but it would be everything in nature demonstrates variation. So I have no doubt that they're going to get variations in the degree of jealousy.
And is it possible to say put them in a brain scanner in order to see which bits of the brain might be involved in making jealousy happen?
Well, I'm always a bit suspicious of lots of the brain scanner research, particularly for things with social emotions like jealousy, because lots of highly social emotions are only produced in social environments, which require quite a lot of more than one thing. So I'm actually I'm actually deeply suspicious of some of the brain scan research.
So do you think it's just pack animals then, where alliances are important, where you're going to see these jealousy type things? So the example we gave of a hamster being jealous if you patting the dog, would that probably not happen?
I would be. There are two things about that. I suspect this sort of emotion only happens in the more complex social species, but also it's probably very difficult to see these. I wouldn't know whether a hamster would ever get jealous, simply because I don't have enough interactive experience. I don't know what a jealous hamster would look like, but I'm pretty certain but I don't think there are many people, if I could show you video, would say that what a jealous dog looks like is actually pretty obvious.
Does your dog get jealous? Does your hamster even get jealous? If you'd like to talk to Paul Morris from the University of Portsmouth, he's here after 8 o'clock, and he'll be quite happy to take your calls. The phone number 0845 30 50 007. Also here in the studio from Leeds University is Crispin Little. Hi, Crispin.
Hi.
Thanks for coming in. You've been studying these deep-sea vents, so tell us a bit about them. Where are they and what are they?
Well, modern hydrothermal vents are found in the deep sea floor where you get new ocean crust being formed. So they're found on the spreading ridges in the mid-Atlantic and in the East Pacific, and also in the Western Pacific as well.
So what's coming out of them?
Well, it's high-temperature hydrothermal fluid, which is actually seawater which has been reacted with new ocean crust at the spreading ridges. And it takes on all sorts of different chemical constituencies. It's got lots of iron and zinc and lead. It's anoxic, doesn't contain any oxygen, and it contains, very importantly, hydrogen sulfide, the smell of rotten eggs.
Why is that so important?
Because this is the compound which actually drives the communities of animals that you find there.
So we had a question the other day, springs to mind actually, that someone said if the Earth had no sunlight, it just had this heat coming out of the seafloor, could life have evolved around a hydrothermal vent from first principles in the same way as it just has elsewhere on the Earth? Could that happen?
I think that's very likely indeed, because hydrothermal vent sites have a huge amount of free available energy and all sorts of different chemical compounds which can be utilised by organisms to actually live. And here we're talking principally of small organisms, microorganisms, which can do all sorts of things with all sorts of chemicals that you can find at these hydrothermal vent sites.
How far back in time do the animals that we know live there? How long have they been living there?
Okay, well, the oldest examples come from the early Silurian in the Ural Mountains in Russia, and these are 430 million years old. So that's really pretty old, and we know that we have communities fully formed there which are utilising these chemical compounds just like they do today.
You've brought some examples in. Please tell us, what have you got?
There's a fantastic thing here. It looks like a lump of concrete that's kind of sparkly and gold, and it's got bits of spaghetti embedded in it. And it smells of farts.
Ah, well, there you go. See, now this is a 91 million-year-old piece of hydrothermal vent sulfide. So what the fart smell actually comes from the pyrite, which is degrading to hydrogen sulfide, and the spaghetti things in there are fossilized tube worms.
Oh, is that what we've got here?
Yeah, so I brought in a modern example of a tube worm as well, which is kind of
more than a foot long, this dried up. It looks like a twig.
It does look a little bit like a twig, but that's actually the tube that the original animal would have lived in. And this thing there is actually very small for a hydrothermal vent tube worm, because the largest species grows up to 3 meters long, and that's absolutely enormous for a deep-sea organism.
How does it get its energy, that worm? How's it metabolising?
Okay, well, now this beast here is actually from a cold seep site, which is where methane is seeping onto the seafloor, which is an analogous sort of community. So what's happening here is that the animal is gaining sulfide from the fluids which are coming out of the seep, but it's not utilised them directly. It actually has symbiotic bacteria in its body which utilises that hydrogen sulfide. And the amazing thing about these beasts when they're adults is they don't have a functioning gut at all. They rely 100% entirely on their symbionts for the energy.
So the bacteria extract the energy from the methane and pass it to the worm?
Exactly.
What's the other thing?
The other thing I have here is a very large mussel from a cold seep site. So this is similar to what you might find on the seashore today, but about 3 times the size.
It's about 7 or 8 inches long. That's
why
really
is it
impressive.
so big?
Well, you see, this again is one of the animals which can utilise or has these symbiotic bacteria, and having these symbionts allows these animals to grow much larger than they would normally on the deep sea floor, because the majority of deep sea bivalves have of which this is an example, are only a few millimetres long. So this thing is a giant, and it's because of having these symbiotic bacteria and having lots of energy available at these methane seep sites and hydrothermal vent sites.
People are quite interested in those bacteria, aren't they? Because they can do some very complicated chemistry at extremely clever temperatures, which means that they might actually be able to help us today with some of the chemistry we want to do here above the surface of the sea.
That's right, yes. There have been some biotech applications of some of these bugs that you find at hydrothermal vent sites, in particular with high-temperature enzymes.
I was thinking mining. People are talking about recovering precious metals from what's left over from mining, aren't they?
Yes. People actually already use microbes for extraction, particularly of gold in mine tips, and I've actually seen some examples of that in the field. So we do use these sorts of bugs that you might find at vent sites, which are actually ubiquitous in places where there's lots of sulfide minerals, for extraction of precious metals.
That's Crispin Little from Leeds University. He's here with us after 8, and if you'd like to ask him any questions about what's going on under the depths of the ocean, you can call in and talk to him, 0845 30 50 007. And both Kat and I are here to take any general science questions you might have too, so keep those coming in. Time now for the next in our series of special kitchen science experiments for the BA Festival. Every night this week, our kitchen science team are paying a visit to a different kitchen around the region, and tonight we're off to Billericay in Essex, where kitchen science gurus Derek and Dave join Rachel, Andrew and Simon to make fibre optics from a lemonade bottle.
Hello there, yes, and welcome to Billericay School. And there is some very, very good feeling here. Firstly, of course, Dave is here with me as well to tell us what we're going to be doing today. What's up then?
Well, this evening, Derek, we're going to be building our own fibre optics out of just a lemonade bottle and some water.
Fantastic. OK, and we've also got 3 helpers, all from Year 12 here at the Billericay School. So could I just get you to give me your names, please?
Rachel.
Andrew.
Simon. Excellent, guys. And can you just quickly tell me, Rachel, firstly, do you do science?
Yep, I do biology.
OK, and yourself, Andrew?
Biology and chemistry.
OK, and is Simon going to trump that?
No, just do biology.
OK then, yeah. But do we all like science here?
Yep.
Absolutely.
Oh, that is very heartfelt there. That's brilliant. OK, so then, what we're going to be doing today, you can do this at home too. So please, why don't you get these things together and you'll be able to build your own fibre optic at home. What you need is a lemonade bottle or some kind of plastic bottle which is perfectly transparent. OK, the larger the better as well. Something to make a nice round hole in it with. Dave's got his drill standing by, but anything will do. But please, adults standing by to supervise with that if necessary, that would be great. And a torch of some sort. And it's best to do this in the sink. OK, otherwise, if you can get all those things together, listen to what Dave tells us to do.
First thing you need to do is to take your hole-making device and make a hole maybe 5 or 6 millimetres across down near the bottom of the bottle. So I'll do that now.
OK, so here's Dave with his drill, and here he goes. So Dave's basically whacked his drill straight through the bottom of that bottle. So it's not actually on the base of the bottle, it's on the side of the bottle, but very, very close to the base. So the hole is kind of pointing out to the side, and the hole is about 0.5 centimetre across. All right then, and what next?
OK, now, Rachel, if you'd like to fill the bottle up with water.
OK, and of course some water will probably come out the hole, so do they need to cover the hole?
It would probably help. Right the way up, fill it right the way up.
OK, so maybe cover the hole with your finger and fill it right the way up with water otherwise.
Is that enough?
That is brilliant. OK, so that bottle is absolutely full and the hole is covered, so no water is coming out at the moment. OK, and then what should people be doing?
What you want to do is get the torch, shine it at the back of the hole and let the water come out and see what happens.
OK then, so what you've got to do really then is have a torch pointing through the bottle so that the light actually shines out of the hole that you have made. So that actually the light really goes kind of into the bottle from one side and then out of the other side, shining out horizontally. So Simon, Andrew and Rachel are ready with it. So please tell us, guys, what you see when you let go and let the water come out with the light kind of coming through behind it.
OK. You can see the light on my hand, which is catching the water from the bottle. And this is because...
Go on, Andrew. Come on, Andrew.
Well, the light is clearly travelling through the water.
So even though the water's gone round a corner, the light's still staying inside the water?
Inside the water.
Yes.
So there we go. The light seems to have bent round through the stream of water that we've got. So what is going on here, Dave?
OK, let's move over to my tank of water over here.
OK, so Dave's actually set up a tank of water to help us explain what's going on here. And it's a circular tank. It's probably about 14 inches across, and it's full of water. And it's kind of placed on a space between two tables so that we can actually get a view from underneath it. And it's actually made out of glass as well. So we're about to be doing some viewing from underneath it, I guess. So, Dave, then, what do we do? OK, Andrew, could you climb underneath the table and look up through the surface of the water and see what you can see?
You can see right through the water.
Now, Simon.
Yeah?
Could you just look through the water, just look it up at it at a very small angle?
OK, so Simon is almost side-on, really. He's not looking from directly underneath. So if you look at the underside of the surface of the water...
Yeah.
What can you see there?
Just like his hand, but it's below the water.
So looking up under the water at a small angle, it behaves like a mirror?
Yeah.
So it's called total internal reflection. If light comes out of something like water at a very small angle, instead of going through it, it will actually bounce off. In fact, an incredibly high percentage of the light will bounce off, and it's almost a perfect mirror.
So then, this thing we did with the tube of water and, of course, fibre optics, how does that all relate to this then?
Well, when you shine the light into the tube of water, it's going to meet the water at a very small angle, so it's going to reflect. So it'll keep reflecting again and again inside that tube of water. This is exactly how a fibre optic cable, which transfers most of your phone calls and the internet, works. All you do is you shine a light in one end, it bounces inside this long, thin glass tube, and it comes out the other end, even though the glass tube's gone around lots of corners.
So, Simon, then, you were the man looking from underneath the water. So is that clear now? Has Dave's explanation cleared that up?
Yes, it has, yeah.
OK, well, thank you very much then to Billericay School in Essex, and we'll actually be in Mildenhall College of Technology in Suffolk tomorrow for our final experiment of the week. And although this one won't be one that you can do at home, it is very spectacular, so please don't miss it. OK, so anyway, it's goodbye from me, goodbye from Dave, and also goodbye from the Billericay School.
Thank you very much, Derek. Now, tomorrow we'll be talking with Hussein Mehmet from Imperial College all about the subject of stem cells. And we'll also have Trevor Cox from Salford University here in the studio to talk about acoustics and also how you can make train announcements a lot more comprehensible when you're at the train station and you can't understand a damn thing they're saying to you.
Well, it's time for your questions to our scientist, Dr. Chris. Are you ready?
We're ready and waiting.
Right, well, first of all, we've got Michael Gilbert, who's on the phone to you live now. Hello, Michael.
Hello, how are you?
I'm lovely. Here's Dr. Chris for you.
Right, I'd like to ask a very simple question. We are all advised and required to move over to digital radio and television in the near future. Right, I've always been a good constant looker at my electricity consumption. I'm lucky enough to have my daughter who's bought me a new GGTV and radio.
Yeah.
At Christmas.
It's nice of her.
Still got my old analogues. So I've been comparing the two. Right, my analog radio uses 0.2 electric per day.
Yep.
1 unit. On the digital, it uses 1.9.
Yep.
On my TV, it uses 0.9 per day.
Yep.
And on my digital, it uses 6.7.
Yep.
It uses basically 7 times more electricity than my analog.
This is when it's on standby or when it's on?
When it's on. I've had everything off and judged it because I'm a good... I'm an old-age pensioner. And I'm sure every bit of what I do is going. Why do I have to change over to something that's going to cost me a lot more money?
I think it's the technology, actually, because if you look at the amount of controls that are involved in making and rendering a digital image and turning it into something that can be understood so that the TV can actually show it, it's a lot more energy hungry to do that. Digital TV has a lot more functions on it than analog. If you think of old analog TVs, they didn't really do very much apart from show pictures. So it's actually not so energy hungry as if you're running enormous numbers of electronics inside the TV to do other things, the teletext, the interactive red button that you can push, and all of the presets and things that are stored inside the TV. So I think that's probably why.
Well, I'm sorry, I don't agree with you. I don't accept that everybody wants that. All I want to do is watch a television when I've got a television.
Well, I'm not telling you to have one or not. I'm just telling you why it uses more energy, to be honest.
I just don't... you're pushing... the government is pushing us to do this, but we're using far more electricity in order to do it. And as you heard today, electricity and gas are going to go up with, 17% in one way, 9% another way?
Well, I think you've got a good observation, which it is more energy hungry, and perhaps you should write a letter to highlight this. But the thing is that...
I've already done it 2 times to my MP, and do you know what? I've had nothing back.
Oh, I'm sorry to hear that.
All right, well, thank you very much, Michael. Thank you for your question.
Bye-bye.
Bye-bye. There's Michael about his digital technology. Now then, Dr. Chris, I understand you've had some emails there.
I've got a nice letter here from Imogen Smith, who wrote to me yesterday. She said, I'm Imogen Smith and 9 years old. I went to the BA Festival of Science and I made a model of some molecules. I found it all very interesting, but I'd like to ask a question that hopefully you can answer. It's always puzzled me very much, but why is the sky blue? I hope you can answer this one because it always sticks in my and other people's minds. Well, the reason for this, Imogen, is that it's all down to the atmosphere that we have around our planet. The Earth's atmosphere is made up of 80% nitrogen and 20% oxygen. And when light from the sun, which is white light, and white light's in fact a mixture of all of the different colours that we can see mixed together, and when they mix they make white light. When that light hits our atmosphere, all of the light comes straight through the atmosphere very easily in a straight line, except for blue light. And blue light, when it hits the oxygen and nitrogen in the atmosphere, gets ricocheted around like a bullet bouncing around in a room. And the consequence of that is that the light, instead of coming in a straight line to your eye, making the sun look white, the blue light comes from all over the place. And so your brain thinks that it must be coming from right across the whole sky, and so it interprets the sky as a blue colour. And it's just because of our atmosphere. Kat?
So why do we have nice red and orange sunsets then?
Well, that's another trick, which is that as the sun sinks lower on the horizon, it has to pass through slightly more atmosphere before the light reaches us. And because more and more blue light gets moved by more and more thickness of an atmosphere, because the light's travelling further, as you take blue light away from white light, you get light that's more and more red. So the further towards the horizon the sun goes, the more orange and red the colour of the light reaching your eye, so you get these nice red sunsets. And the other thing that can make that happen a bit more is if there's a lot of dust or particles in the atmosphere, because particularly around harvest time, or if we've had, for instance, a lot of pollution, a lot of fires, forest fires, or perhaps even if there's been, say, a volcano blowing up. When Mount Pinatubo blew up in the Philippines, we had some fantastic sunsets because tiny particles in the air accentuate or aggravate the effect, and you get even more redness.
And if you're interested in what's up in the sky at the moment, if you're standing near a window, go and look out at the moon. We're currently in the middle of a lunar eclipse where the Earth is coming between the moon and the sun, and you can see the top corner of the moon's been sort of eaten away there. That's an eclipse. That's
Thanks,
our
Kat.
Earth.
That's all our audience gone for tonight.
Sorry.
Anyway, Sue, back to you.
Not down to the bigger bottom being back then. It's a partial eclipse tonight anyway in Pisces, isn't it? So we can't be too sensitive. Now, we've got Gary from Kings Lynn on the telephone. Hello, Gary.
Hello.
Hi, you're through to Dr. Chris.
Hi, Gary.
I want to practice smoking, and I want to know the benefits of being hypnotised or what it does to me.
OK. Well, let's just look at smoking for a second. Well, about 75% of people who smoke want to give up, but only about 25%, if they're very lucky, and roughly about 7.5% of people in an average year actually succeed. So it's very hard to quit. What actually affects your quit rate? Well, if you just try and go cold turkey, as I say, about 7.5% of people will succeed. If you do things like get some advice from your doctor who will encourage you very strongly to give up smoking, that number rises to 10% perhaps. Then you can start doing things like taking nicotine replacement therapy, NRT. And if you have nicotine replacement therapy in the form of inhalers or gum, you can get your success rate to about 15%. Then you could take drugs. Now, there are some drugs that you can use, and Zyban is one of them. That gets the success rate up to maybe 25, maybe even 30%. Is hypnosis any good? Well, when people applied hypnosis to this trial, to these people in this sort of group, they found that it might get your success rate up to about 15%, because it gives you a bit more mental fortitude, a bit more encouragement to try to quit. But let's ask Kat Arney, because she's from Cancer Research UK. What are you advertising or advising people to do?
We're just advising people to try and give up in any way they can. The NHS Quit Line is very helpful. There are the sort of methods you talked about. There's nicotine replacement. Anything that works for you, because smoking still causes 25% of all cancer deaths in the UK. So if that doesn't sort of sober you up and get your mind motivated, then I don't know what will, really.
It's 132,000 deaths every single year attributable just to smoking. It's the equivalent of a jumbo jet crashing every single day, the deaths due to smoking. It's a lot of deaths, so it's really worth trying to stop.
Yeah, I did try the nicotine patches, but in all honesty, they weren't a great deal of help.
Sure, if it's any encouragement, James Bond said, giving up smoking's easy. I've done it hundreds of times.
I can't answer that one.
Good luck.
All right, thank you very much then, Gary, and good luck.
Bye-bye.
All right, take care. Dr. Chris, got an email here from Maria, who's listening online somewhere in Suffolk, who says, how do bumblebees know their way home to the hive?
Oh, fantastic question. Bumblebees navigate via ultraviolet. They're able to see UV, which means even on a cloudy day, they know where the sun is, and they have a body compass, and they know how far they've flown in any direction relative to the sun, and they also have a body clock, and they therefore can time their body clock relative to where the sun is in the sky, and they adjust the direction they fly in to compensate for the fact that the sun has moved a bit between the outward journey and the homeward journey. The average bumblebee has a range away from home of at least 10 miles. It can go 10 miles from the hive and still find its way home again. It's a staggering ability of feat of navigation, but they do it with UV light to navigate via the sun.
And don't they also use amazing dances to tell each other where the pollen is?
Well, that's honeybees that do that. But,
not just bumblebees.
Well, I don't know whether bumblebees resort to the same trick.
Do you know why bees hum?
Because they don't know the words.
You got it.
Oh, I've heard you tell that rubbish joke before.
Thank you very much for that one. Next up, we do have Paul, who's in his lorry, on the telephone for you. Hi, Paul. You're through to Dr. Chris and Dr. Cat.
Hi.
Hello, Paul.
Listening to you last night, you were on about lava and thermals and magma and stuff like that.
Sure.
It just dawned on me that in the same sphere where you've got the thermals and stuff that are producing the steam and that, you've got nuclear power stations that produce steam, well, heat water to produce steam to generate electricity.
Yeah.
And I wondered why nobody has harnessed any of the heat to create or the steam.
Oh, they have. They have, very much so. Iceland produces the most spectacular bananas just thanks to all the heat coming out of the air. I mean, Chris, you must have some figures on how much energy we think is being shed by the planet into the seafloor, for example.
Well, yes, it's a huge amount, and if you could harness all that energy which has been come out of these mid-ocean ridges, then you'd have enough energy for the rest of all time. But the problem is actually how do you harness it from the deep sea? Now, you can do it on the land, and many countries, like Chris suggested, already do this, like Iceland and New Zealand have a lot of geothermal energy. So there's enough energy coming out of the surface of the planet that we could boil kettles for forever. But the point is, how do you actually get it?
When you go down a coal pit or anything, obviously the temperature increases the deeper you go into ground.
Yes, the classic example of the gold mines in South Africa, where it gets very, very hot because they're so deep, several miles deep.
Yeah, there's nobody tried anything like heat pipe technology. You know, a big deep pipe down in with water to generate steam that way? Or?
Well, they do, and I think Southampton had a hot rocks project at one time with geothermal energy. You would pump water down to where the rocks are hot enough, and it just extracts that heat from the rocks, turns the water into steam, and that steam's used to drive a turbine and produce some electricity. There are a number of problems, though. One is, are the hot rocks near enough to the population to make it viable? Because it's all very well plumbing in pipes, but if you've got to spend so much money on the pipeline and so much money on insulating the pipeline, you've actually made it worse for the planet in terms of pollution you've made than actually the energy that you've recovered from the planet itself. Chris?
It'd actually be better to do this for individual houses, because there's just that small amount of heat transfer combined with all the other power systems in the house would make that bit of difference. And of course, if you do it for every single house, then overall you make a big difference. But of course, it costs money to put these things in the first place. So if government decided that that's what people wanted to do, then they could perhaps bias the tax system so you could actually have that happen.
But is every house going to be in the right place to use this, Chris?
Pretty much so, because everywhere where you dig into the ground, just the pressure of the ground above it will give you a slight temperature differential.
But how much money would you have to spend on the kit to extract that? The payback period would be quite long, wouldn't it?
Well, it would, and of course this is where government has to come in. You could say the same thing about little turbines for each house. It's all very expensive to put in, but if you decide that's less expensive than building a load of nuclear power stations, then Bob's your uncle.
That's the best we could do, Sue.
OK, right, thank you very much then, indeed, and thank you to you, Gary, as well. Sorry, it's Paul, wasn't it?
Yep, thank you.
Sorry, Paul, getting myself mixed up then. Questions coming in, a couple of animal ones now.
Excellent.
Margaret from Corby, this one's just come in here. She says, why do some frogs let you tickle their bellies?
Oh, over to you, Paul.
Well, I can't say that frogs are one of my top areas of expertise, but
I mean, you don't tickle their bellies.
I will make it one of my top priorities for the weekend. Now, I interacting with amphibians, I haven't spent a lot of my time doing so. If anybody out there can come up with an explanation, I'd be very interested.
Maybe she meant French people.
Perhaps, there you go. And also Judy says, why does my older dog destroy everything I buy for my puppy? This has been going on for 2 months now and it's costing me a fortune.
Probably because, without actually seeing them interact and seeing the nature of the relationship, but it wouldn't be beyond the bounds of possibility that the dog is actually could be a form of jealousy behaviour that's actually trying to destroy something that's important to somebody else. I have seen it, but there isn't a huge amount of documentation. But just because there's not a huge amount of documentation for it doesn't mean it doesn't exist.
Is that why dogs, if you leave them at home all day and go out, then they kind of eat the sofa?
I would think there's a sort of... a simpler explanation is they're just bored and they're just this type of self-stimulation activity.
That's dogs for you, isn't it? And one last one here from Harry from Margate, who says, Dr. Chris, why do I get sunburn in the UK for 1 day, but when I was in the Philippines, I did not get it at all?
Well, it could have been because once you have had some sun exposure, the skin actually produces a hormone which makes melanin. Melanin is the suntan. It's what makes skin go brown. It's a dark molecule which soaks up UV radiation and stops the UV getting into the lower reaches of the skin where it can cause damage. And once you've got a basal suntan, a so-called overall skin suntan, it's like a suit of armour which reflects off the UV, so you don't get more UV exposure. But in the UK, where the sun is actually not very sunny for a large part of the year, suddenly you'll have a hot day, you've got very pale skin because you haven't had much sun exposure up until then, and so there's nothing to protect you. And then all those UV rays go straight through the skin and cause a burn, and that's why you suddenly burn. And that's actually the worst kind of burning, because you haven't actually had any sun exposure up until then, and then you get a very big dose of UV, but nothing to protect you, and so that's what's most likely to cause skin cancer in the long run. I think you'd probably agree with that, wouldn't you, Kat?
Yeah, absolutely. It's always the first sunny weekend of the year. You see everyone out, they all get sunburnt because they don't believe the UK sun can actually burn. But there's something to do with the UV index as well, particularly when the sun's very strong in the summer, and at the really hot times of the day, you're most likely to burn. If you're on holiday, you might put more suntan lotion on, you might stay out of the sun in those hot times, so it could be that reason.
It's fierce stuff out there, isn't it? Well, thank you both for yet some more interesting and fascinating facts. You're there again tomorrow, aren't you?
Yes, tomorrow we'll be joined by Hussein Mehmet from Imperial College and Trevor Cox from Salford, and we'll be exploring stem cells and also acoustics, how to make nasty sounds, and also how to make train announcements a little bit more comprehensible. And Trevor Cox is actually famous for 3 years ago proving that a duck's quack really does echo, despite the urban legend that it doesn't.
Ah, that's what it is then. My ducks are nocturnal, you know, and you get home and you open the back door, let the dogs out, so they go, and it's just drives you crazy. And
Well, they're warning each other that the dog's about to eat them.
No, not at all. They will get on really, really well. As long as everybody has a piece of bread, everybody's happy. See, they're all well fed in our house. Thank you very much indeed, Chris. And Maria gave me a little email to say thank you very much. She was the lady with the bee question who said, I've always wanted to know that.
Oh, I'm delighted we've made someone's evening.
All right, lovely. Speak to you again soon, and keep naked.
Live from Norwich with the best of the fest, the Naked Scientists.